We're working with standard and vertex form today. So, as you know, this is our standard form, this is our vertex form. Yesterday we talked about relating the vertex form to the standard form, or in other words, changing one into the other. And when we change our vertex into standard form, what's that process called? Expanding, usually known as expanding and simplifying. We're going to say expanding. Okay. Today, we're going to learn how to take standard and turn it into vertex form, which is known as completing the square. Okay? Now, what I want you to notice with completing the square is at one point, or in our vertex form, we have a bracket that is squared. In other words, if you guys remember from doing perfect square trinomials, that means that there are two brackets that both have identical values in them, so you can represent it as one bracket. Our goal here is to create a perfect square trinomial so that when we factor it, we get this effect. Okay? So, there's a process we have to go through. What we're going to do is, to start off, we're going to take the a value of standard form, which is 3, and we're going to divide just the first two terms by that amount. When we divide it by that amount, in other words, what we're doing is taking out a common factor. So we'll get f at x is equal to, our 3 will come to the outside of the brackets, and we're left with x squared minus 12x, and then the 50 will be outside of the brackets. Okay? What we're aiming to do is, in these two brackets, is create a perfect square trinomial. Right now we have a binomial. There's only two terms. Okay? We also, when we do this, we want the x term, when we factor it, to be just a value of 1. And the reason we want that is because in vertex form, there's only a 1 in front of the x. We don't want a value that's larger. That's why we take out our a value. Okay? So from step 2, we have to do a bit of side calculating. The way we remember it is we call it the b term, and we say we divide b by 2 and square it. So this is our little formula, b divided by 2 squared. Now, originally our b was this negative 36. But when we apply it, we're applying it to the second step after we've taken the a out. So our b is now 12, or negative 12 if you want to say. So we have a negative 12 divided by 2 squared. What's negative 2 or 12 divided by 2? Squared is 36. Okay. Now, what I'm going to do with this 36 is I'm actually going to be adding and subtracting it. Now, think of it like this. We have an equation. If I were to just add 36 into this bracket, it would make this a trinomial. But whatever I do to one side, I have to do to the other, right? And then we'd have a bit of an imbalance. We don't want numbers on the other side. So instead of doing that, what we're actually doing is we're adding and subtracting it in this bracket. If I add 36 and subtract 36, what's that the same as? What do those equate to? 0. So it's like adding a 0. I'm actually not changing anything. I'm keeping my one side balanced by doing this. Okay? So we'll then have 3x squared minus 12x, and we'll be adding 36 and subtracting 36 in the bracket. Okay, now if you notice, I have 4 terms here, and we need a perfect square trinomial. So I got to take the negative term and take it to the outside of the brackets. Okay, so in other words, when I take it out, technically this 3 here needs to be distributed to all the terms inside. So when I take it out, I have to remember to multiply it by the front term, which is 3 in this case. So we take the negative 36 out and multiply it by 3. So our next line will read 3x squared minus 12x plus 36. And on the outside, negative 36 times 3 is going to give us negative 108 plus 50. Okay? Give me 1 second. Okay, just a second. From there, we've created our trinomial. Remember, in vertex form, we want two brackets that are the same, so they're written with a square. This is our trinomial. Now, I'm going to show you how to factor over here, and then I'm going to show you the shortcut. Because assuming we've done everything right, I can factor a perfect square trinomial very quickly. But I'm just going to prove that it's a perfect square trinomial over here. So we have x squared minus 12x plus 36. I take the factors of 1x, or just 1 and 1x. Factors of 36, well, we have 1, 36, 2 and 18, 3 and 12. And the one that's very important to us is going to be 6 and 6. Okay? I think 4 and 9 also go in. 6 and 6 are very important to us because I know that I'm going to need to multiply 6 by 6 to get our negative 12. Now I need them both to be negative in this case to add up to negative 12. So our bracket when we factor this would be x minus 6, which can be written as what? X minus 6 squared. Okay. Now, you could do that and factor this whole thing the way we've done it over here. Or, since we know we've made a perfect square trinomial, I can find the square root of the first and the last term. This is a shortcut. Now what I'm going to do is I'm going to have 3. I know it's only going to be one bracket squared. The square root of the first term, what is the square root of x? What's the square root of 36? Okay. And then I just take the operation of the middle term. What is it? It's a negative, so we bring down a negative. We have negative 108 plus 50, so our last step is to simplify what's outside of there. So we get 3x minus 6 squared, and this will become negative 58. So our vertex is at 6 and negative 58. Okay, so what we've just done is we've changed standard into vertex form. One example.